So we are discussing the bending stress in the last chapter, right? So we will solve one more problem in that category. Now, try to see this question. A beam of span 3 meter and width having 90 mm is loaded as shown in the figure. If the allowable bending stress is 12 megapascal, calculate the minimum depth that is required for the beam. So we need to calculate the depth of the beam for this particular question. That is recently asked in engineering services paper. So here, first of all, in this question, the main aim is to calculate the maximum bending moment, right? Because you know that when sigma b maximum value will be less than or equal to sigma permissible value, till that whatever the design of the beam is there, that is correct. The moment sigma b will be more than sigma permissible, it will fail, right? And what is the sigma b maximum value? We know that sigma b maximum value we can calculate m y maximum by I. Simply I by y, we know that z value, that is z maximum. So simply I'm writing m maximum by z. Z maximum is what? Section modulus. Maximum section modulus can be calculated along the maximum maximum section modulus can be calculated along the what? Neutral axis only, right? So whatever you say, neutral axis, section modulus about neutral axis, or section modulus, maximum section modulus, both are same thing. Sigma permissible. So maximum bending moment. What is the Z maximum for? Suppose that it's a rectangular cross section which is having a width B and depth D. You know that Z neutral, suppose this is the neutral axis, and neutral axis section modulus will be what? BD square by 6. How we got BD square by 6? Z neutral axis will be what? I by Y maximum. I with respect to neutral axis by Y maximum. And I about the neutral axis will be what? B into dq by 12. Y maximum will be d by 2. So we can calculate BD square by 6. So from here we can calculate BD square by 6. And that is what I'm going to put here. Sigma permissible, I'm going to call sigma P. 6m divided by B into sigma P must be less than or equal to what? D square. So minimum to minimum depth will be required is what? Under root of 6 maximum bending moment divided by what? B into sigma P. That is what your answer. Understanding my point, all of you? All of your understanding? Tell me, guys. Yes?
Yes, sir.
Yeah, you can write in the chat section. Now, the moment we got the minimum depth formula, in that minimum depth formula, we have the maximum bending moment. How to calculate the maximum bending moment? That is what the next question mark. How to calculate the maximum bending moment? That is what the question mark we have. How to calculate this one? Tell me, guys. How to calculate this one? Maximum bending moment will be what? In this beam, this is the reaction A. Suppose that this is the reaction B. Suppose that This is C point, D point, E point. In whole beam, at all the points, try to calculate the maximum bending moment. Where it will be maximum, tell me. At the ends, it will be 0. At the hinge support, it will be 0, my dear friend. Then where exactly it will be maximum? Where exactly it will be maximum? All of you, please let me know what will be the maximum bending moment. It is very similar to the symmetric kind of nature, right? See, the loads are equal and the middle loads are somewhat different, but the distance will be same from each end, right? So we can calculate, yes, we will try to find the middle one. Let's see how it goes. First of all, tell me RA and RB value. RA and RB value will be what? RA and RB value will be what? RA and RB value will be what? 12 plus 12, 24, 24 plus 5, 29. 29 divided by 2, that will be answer. 29 divided by 2, that will be answer. So 14.5 kilonewton, that is a reaction value. Now try to calculate the middle one. At the middle one. So bending moment at D will be what? Bending moment at D will be what? 14.5 into 0.6 plus 0.9. That is what? Sagging bending moment minus of what? 12 into 0.9. Now if you just calculate, you will be getting what? 10.95 kilonewton meter. Once you got the maximum bending moment, definitely you can calculate at each and every point and you can verify this is going to be what? Maximum value. This is going to be maximum value. This is going to be maximum value. Now, once we know this one, so we can calculate D minimum by using this formula 6M maximum. What is the M maximum? 10.95 into 1000 into 1000, that is kilonewton. I am converting in Newton, and 1 meter is what? 1000 mm. So from here to here, divided by what? B. What is the B value? 90, and this value is what? 12. Now if you just calculate, so you'll be getting approximately 246. 246 you will be getting, right? You should be able to get how to calculate the square root. I know the I'm assuming that you know this particular thing, how to find the square root of any value, right? Of course, this question has been asked in engineering services, so there also we don't have any calculator. Remember, sorry. So note down quickly, then we can move on to the next question. Is it done, all of you? Done, right? Everyone? No. So yeah. So all of you can try this question. All of you can please try this question. A steel wire of 10 mm diameter is bent into the circular shape of 5 meter radius. What will be the maximum stress induced while applying the bending? There must be bending stress that will be introduced in the wire. That is what we need to calculate. Just think, take some time, 1 minute time, and try to tell me the answer. Very important. $200. Okay. 200 is right answer. Those who are getting, let me know. Those who are getting the 200 as answer, please let me know. Any one of you? Got any answers? So here there is a trick. We have to use this particular formula. M by I sigma by Y will be equal to E by R. So here we need to calculate by using this formula. Do not use any formula regarding this bending moment calculation because we cannot calculate the bending moment, right? So there is a steel wire which is maybe of having some length and diameter. That particular thing I have just applying the bending moment and I have converted this into what? One circular arc. That means in circular shape of having the radius what? 5 meter. What will be the bending stress that will be introduced in this one wire that they are asking. So let me draw the diagram carefully. This is a circular arc, suppose. Circular ring kind of thing will be there. Now, my different. So where the neutral axis will be there, the neutral axis will be what? Exactly at the middle, my different. Exactly at the middle will be passing through like this. This will be my neutral axis. Yes or no, guys? Yes or no, guys? Then what is the sigma B maximum value? E into Y maximum by R. How to calculate the Y maximum? That is what the question mark. That is what the question mark. Y maximum, always remember I told you in any figure, Y maximum will be the distance from the neutral axis to the extreme fiber. The distance from the, if I just draw the view like this. So this is what the neutral axis is there. And this is what the distance, my dear friend. Y maximum. Now, can you please tell me what will be the Y maximum will be the value? All of you can please tell me what will be the Y maximum value? All of you please tell me. Can I say it's directly D by 2? Can I say it's a D by 2? If it is D by 2, why it is D by 2? Tell me. The distance from the neutral axis will be, why it is D by 2? So this radius is what? 5 meter. So this radius is what? 5 meter. So this is, we are not bothering about those things, right? So now this Y maximum will be what? D by 2 only. This Y maximum will be what? D by 2. See, this is the wire of diameter D. This is the wire of diameter D. Y maximum will be what? D by 2 only or not? Y maximum will be D by 2 or not? Check it out. All of you please check it out. Y maximum will be, the distance from the neutral axis will be D by 2 or not? From here to here. This distance will be D by 2. From here to here. It will be Y maximum. Not from the centroid. Not from the centroid of that circle. No, no, no. That is a wrong confusion. I mean, there is a misconception about those things. The distance will be there from the neutral axis always. Remember like this. E value is there, 200 megapascal, 200 gigapascal. Y maximum is what? D by 2. Diameter is given what? 10 by 2. The radius of the curvature. Suppose you are bending. What will be the radius of curvature? That is what they are given as 5 meter. That is 5000 mm. So 540. What will be the answer? 200 will be the correct answer, right? Similar question has been asked in GATE 2019 also of 2 marks. right? But instead of that circular wire, instead of steel wire, there was a square wire. There was a square wire. That particular thing they have bent it into what? In the form of circular arc. Understanding or not? All of your understanding? The main role is to be played by what? The main role will be played by this thing only, by maximum. Very important. Now, once it is done, then please let me know. Yes. What you are asking? It's not a related question, but you have advice to solve ESC objective. Do you know any good book which has accurate solution? Accurate solution means, uh, you know, okay, I will mention. See, so you are solving previous year of ESC examination, right? Praveen. I have messaged you about this thing, about the textbook that you can purchase. It's a perfectly fine. Most of the things are accurate there, and even you can find the solution also, right? But if you just follow other publication, so they have some difficulty, right? They miss some good question actually. They directly provide the answer, do not provide the solutions. That's a problem with that, right? Now try to solve this question and let me know the answer. Online, I need to see. I need to see in the Telegram. If I'll find suitable sources, I will send you directly. I'll just find the PDF of all the, in a combined format of ESC paper, all the paper of all the years. I will see that. So it's one of the simple problem. So here it's a bending stress in the beam cross section at a distance 15 centimeter from the neutral axis, right? Determine the magnitude of the bending at a distance of 10 centimeter from the neutral axis. They are asking. So here they might be having the shape of the beam. Suppose I'm assuming that it should be, rectangular cross section. Now the distribution will be something like this. Suppose that. Suppose the distribution will be like this. The bending stress in the beam at a distance 15 centimeter. Suppose I'm taking extreme fiber only, 15 centimeter. From the neutral axis, the bending stress is what? Suppose 50 megapascal. Determine the magnitude at a distance what? At a distance 10 centimeter. From the neutral axis, they are asking. So it's a very simple. It's a very simple. See, sigma b value is what? My by I. The bending moment is same. I about the neutral axis will also be same. So sigma v will be directly proportional to I for same bending moment. See, for each and every point, the bending is for bending moment will be same. Whatever the bending moment we have applied to this particular thing will be same only. I about the neutral axis will also be same for same bending moment, and I about the neutral axis. So now suppose this is what sigma 1 and this is my point number 1. Suppose this is the point number 2, I need to calculate. So sigma b2 by sigma b1 will be y2 by y1. So what will be the y2 value? 10 centimeter, and it is what, 15 centimeter. So from here, what will be the sigma 2 value? Sigma b2 value will be 10 by 15 into 50. So what will be the answer? 500 by 15. So if you just calculate 33.33, it will be coming, right? Check it out. All of you, please verify it. Right? Done, all of you? Is it done? Done, all of you? Perfect. Try to solve this last problem, then I will start shear stress. Then I will start the shear stress. Very important. Very, very important. Somewhat tricky, but it's a good problem. So whenever, what do you understand by dot and cross? In a particular cross section, if suppose it is mentioned like this, cross, then what is it? What is the meaning of this thing? What is the meaning of cross? Dot and cross. Anybody know? If anybody know, please let me know. So whenever the forces are acting towards the cross section, whenever the forces are applied towards, yes, whenever the forces has been applied towards the cross section, then it is a cross symbol. Whenever the forces has been applied away from the cross section, then it is just represented like a dot. Then it is represented like a dot one. So here they mention dot. A pull of 10 kilonewton acts on the bar. That means the force has been applied perpendicular to this one, this particular figure. Assume it is a perpendicular direction to this particular axis, y axis. Now I different. And that pull is what? 100 kilonewton. In such a way that it is parallel to the bar axis. It is parallel to the bar axis and 10 mm away from that particular axis. What will be the maximum bending stress induced in the bar at a particular what? XX distance, they are asking. Now tell me, this particularly load, this load will be able to create the bending load, a bending moment or twisting moment about XX. About XX. You can just think of very carefully. Take your time and let me know. Very good problem. It's a very, very good problem. See, whenever the bending, whenever the movement is acting, whenever any movement is acting perpendicular to the cross section, or it is just acting along the longitudinal axis, that particular movement is called as bending moment. Whenever any movement is acting along the longitudinal axis, x is what? This is the longitudinal axis. This is my longitudinal axis. This is the cross section that I have shown you. The beam might have something look like this. The beam might have look something like this, where x-axis is what? This axis, and we have applied movement about this axis. We have applied the movement about this particular axis. We have applied the movement about this particular axis. Then what will happen? Is it same or different? Z-axis will be perpendicular to this plane of the figure. Y-axis will be this one. Tell me, guys, how to find the sigma b maximum or sigma b at xx? The formula is what? Very simple formula. Nobody can deny from that. But the problem is what? With the y value. The problem is not with the m value. The problem is not with the I value. I you can calculate about the neutral axis. About xx you can calculate, that is 50 into 80 cube by 12. Bending moment, that also there is no problem at all. P into distance, that will create the bending moment. 100 into 10 mm. That is what kilonewton mm. I am getting the bending moment also. But the problem with the y value, guys. what will be the y values that we need to take. Whether we need to take this distance or we need to take this distance. That is what the, this extreme fiber or this extreme fiber that we need to consider. That is what the question mark. Take your time and let me know. See, when this load and it is just taking the, when this particular load is making the movement about x axis, my dear friend, whenever it is making a movement about x, it is just similar to like this only. It is just similar to like this only. And whenever it is making the, the bending moment about that axis, whenever, see, x-axis is not something like this. Let me just make you clear. X-axis is not something like this. X-axis will be something like this. X-axis will be something like this. Check it out. Perpendicular to the laptop screen. Can you check it out? Perpendicular to the laptop screen. Check it out. X-axis will be perpendicular to the laptop screen. Perfect. Perfect. Because that is what that is shown in the figure that has been clearly mentioned in the figure. That is cross section. X-axis and y axis they have mentioned. That means this is axis what? This axis will be z axis, my dear friend. This axis will be z axis, my dear friend, right? Now, so whenever we have the bending about x-axis, bending about x-axis, then we need to take the distance y from the x only. This distance will be counted as y. That is what we have, what? 40 mm, right? Understanding or not, all of you? M is what? 100 into 1000. Y is 40. 50 into 80 cube by 12. Very important, guys. These things are very important. You will get the answer as B. Now, some of you might be thinking, sir, why not this distance? Why not this distance? See, whenever the bending will be happening about this axis, whenever the bending will happen about y-axis, then you take the y from the what? Y-axis only. Then you take the y from the what? Y-axis only, right? So whenever in the formula, suppose you are calculating about x-axis, suppose you are writing x-axis, then please write y about what? Y will be there. Y is showing is what? Y is showing the distance from the x-axis directly. That is the meaning of this. Under which condition I can just take the y value to be 25? When we are applying the loading condition like this. We are not bending in the vertical plane. If you bend it in the horizontal plane, when we bend this particular beam in the horizontal plane about the y-axis, in that case we will take the distance what? 25 mm. Understanding or not? When we are applying the bending moment about y-axis in the horizontal plane, when we apply the bending moment like this, then we can say that it is what? The distance of y will be what? 25 mm, right? Please check it out. All of you, please check it out. What you are saying? We will transfer the given into the load and the moment at center. At section x bending stress is 0. Then right. So why they ask the maximum? No. You are just assuming it to be wrong. Understand the meaning. See, I told you that whatever the stress value they have shown you, whatever the bending stress, yesterday lecture you have not attending, I think. Whatever the bending stress distribution we have seen, that is not in the plane of cross section. That is acting in the perpendicular to the plane of cross section. That is not something like this. See, suppose shape of the beam is what? It has been shown the shape of the beam something like this. Suppose that the shape of the beam is something like this. Now we are not applying the bending stress distribution diagram. We are not drawing like this. This is incorrect. This is incorrect diagram. The bending stress can only be seen over here in a perpendicular to the plane of the cross section. in a perpendicular to the plane of the cross section, my dear friend, right? And whatever you are saying, that is different thing. They are not asking at the neutral axis. They are asking that what will be the values of, maximum bending stress produced in the bar at XX will be what? That means what about the bending stress about XX? In short, that is what the meaning. Understand this thing, right? Correct. All of it done. So the question must be the maximum bending stress produced in the bar about XX axis, right? The perfect name should be what? About XX axis, right? Understanding or not? Because exactly at XX, definitely whatever you are saying that is correct, 0. But 0, there is no answer. So you can say that about XX, about XX will be the correct, particularly, framing of the question. Yeah. Done, all of you? Is it done? Done, all of you? Yeah. So note down the shear stress in the beams. Note down the shear stresses in the beams. That is a very, very important concept. Till now, we have seen the bending stress. But what happens when there is a shear force is acting in the beam? Because of the shear force, the shear stress will be introduced. Because of the shear force, shear stress will be introduced. Shear stress will be introduced in the beam. Introduced in the beam. Very, very important, guys. The formula which I'm showing you right now, the formula will be important. And it is very, very important for you guys to remember this particular formula, right? So whatever the formula, I will be just, writing after this slide. Now, once it is done, then please let me know. Is it done, all of you? Done, right? Yeah. So note down the formula. Shear stress developed. Shear stress developed at a fiber on the cross section of beam. The shear stress developed at a fiber on the cross section of the beam. That is tau formula which I am going to show you right now. P into A y bar divided by I about the neutral axis into B. First of all, note down the formula, then we will discuss each and every term. P is nothing but the shear force on the cross section of the beam. On the cross section of the beam. A will be area. Whatever the terms and terminologies which I am saying you, that is very, very important. Area of the hatched portion. Area of the hatched portion on the cross section. On the cross section of the beam which is above the fiber, where the tau to be determined. Now, that is what the meaning of A. Not only meaning of y bar, the distance of centroid of hatched portion from the neutral axis of that cross section. Right? B will be width of the cross section where tau needs to be determined. A into y bar, the product is called as A into y bar. The product will be called as the first moment of area. The first moment of area. We will discuss by one example. With that example, believe me, each and every term will be clear. The first moment of area. The first moment of area of hatched portion about the neutral axis of that cross section. Whatever the cross section we are talking, that particular cross section, first moment of area about the neutral axis. So please note down, these are the important formula. So if you want to calculate the shear stress, this is the formula, my dear friend. Is it done, all of you? All of it done? Shall we start the derivation part? That is very, very important, guys. Yeah, please note down. Okay. Yeah. So, okay. Now, so first of all, we will try to explore the formula for the rectangular cross section. Rectangular cross section. This is what the neutral axis, my dear friend. Suppose I need to calculate the at a distance of y, at a distance of y, I need to calculate the top. This is the fiber. At this fiber, AB, A dash, B dash, I need to calculate the top. I need to calculate the top shear stress. Now, how to calculate this one? So first of all, note on the formula F up, sorry, P into AY bar divided by I into multiply with the B. This is what the formula I have. What I told you, consider the, first of all, that layer you know, A dash, B dash. First of all, tell me what is the area? Check it out. Area of the hatched portion on that cross section of the beam, which is above the fiber, where we need to calculate the top. That means above that fiber, we need to take the area and we need to just hatch it, mark it for the marking purpose. For that marking purpose. Now, suppose the total depth is what? D, and width is what? Suppose B. Then what about this particular distance? D by 2. Then tell me area of that cross section. Can I say D by 2, sorry, D by 2 minus Y? Can I say D by 2 minus Y into B? Check it out. Each and every terminologies, please match with that and then please let me know. Correct? Perfect. What about the Y bar? Now again come back to the notations. The distance of centroid of hatched portion from the neutral axis of that cross section. Of this cross section, we need to take the centroid. We need to take the centroid. This will be the centroid of this cross section. This will be the centroid of this cross section. And I need to take the distance from here to here. I need to take the distance from here to here. This will be my Y bar. How to calculate Y bar? It's a very simple. It's deadly very easy. First of all, whatever the height will be there, this height, you just take half of that. That is D by 2 minus Y by 2 plus Y. Check it out. So can I write D plus Y by 2? Or 4? Or 4? D plus Y by 2 or D plus Y by 4? Or it's, no. So D by 2, no. D by 2 minus Y plus 2Y total divided by 2. So D by 2 plus 2Y by 2. That will be the correct one. Please note down. So once you have the Y bar value, and what is the width of that cross section? Width of the cross section will be B only. B only. Note down. Very, very important, guys. Very important. Is it done, all of you? Now put the value in the tau. Put the value in the tau. P into A, that is D by 2 minus Y into B. Y bar is what? D by 2, sorry, plus Y. Nobody is telling me also. D by 2 plus Y by 2. Yeah, I have written only. Plus Y only plus Y. Minus Y plus 2Y, that is plus Y only, by 2. I about the neutral axis. What about the I about the neutral axis? B into dq by 12 into B. So what will be the values of tau? what will be the values of tau? A minus b, a plus b, a square minus b square. That is going to be a square minus b square. B and b will cancel out. 2 and 2, that is 6p. 6p divided by bdq into what? D by 2 whole square minus y square. This is my tau value. Note down, very important. Now, if I will ask you the tau value at the neutral axis, what you will answer me? You will put y equal to 0 or not. When you are moving the y from the neutral axis, at the neutral axis means y equal to 0. And that is going to be what? That is going to be what? When y will be 0, when y will be 0, what will be the answer? What is going to be answer? 6p divided by bdq into d square by 4, you will be going to calculate as 3 by 2 p by bd. That is what the tau about the neutral axis. You know that whenever we are applying any force parallel to the cross section, any force we are applying parallel to the cross section is what? BD. We can calculate average shear stress as P by BD. Am I right? We can calculate whenever we apply the force parallel to the cross section, we can write P by BD. That means tau at the neutral axis will be 1.5 times of tau average. Calculate tau at the top fiber. That means at a distance y equal to d by 2, tau will be 0. Bottom fiber also 0. That means at the neutral axis we are getting what? Tau maximum. Very, very important, guys. Note down, very important. All of you are understanding my point? All of you are understanding this particular derivation for this rectangular cross section? Perfect. Perfect. So now once it is done, then please let me know. Done, all of you? So we'll try to draw the diagram of shear stress distribution. We will try to draw the diagram of shear stress distribution and how the tau is varying with the y parabolically. How the tau is varying with the y parabolically, right? It is something like this. Y is equal to a square minus x square, something like that. It is varying. That means it's a parabola equation. So if it is a parabola equation, we can just write the distribution for that. This is B, this is D. This is what the neutral axis you have. This is the top fiber, bottom fiber, neutral axis. And you know that value of the tau, right? So you can draw the parabola like this. Tau at the neutral axis, that is equal to what? Tau maximum. Please note down. This is what you have, the shear stress distribution. Shear stress distribution, right? So whenever the beam, if I take any beam, suppose it is made up of rectangular cross section, This particular beam will be subjected to what? Bending moment as well as shear force. Both will be applied. And what will be the diagram of bending stress distribution? Will be like this. At the neutral axis, it is going to be 0. And at the extreme fiber, it is going to be maximum. Note down, very important, bending stress distribution. Bending stress distribution, sigma B maximum. Yes. Note down, this is the note number 1. Note down note number 2. Note number 2 is very important. Whatever the formula we have seen, tau maximum, that is 3 by 2 times of tau average. Note down, this formula is valid for square cross section. This formula is also valid for triangular and rectangular, of course. Note down, very important. Sir, what about the other shape? Other shape value will be what? Suppose this is a K value. I'm assuming this to be K times of tau average. So K value will be 3 by 2 for this. Note down, K value will be equal to 4 by 3 for circular cross section. All of you understanding what I'm saying? K value will be 9 by 8 for square diagonal. Square diagonal. Whatever the square section is there, we just rotate it with a 45 degree. That is what the square diagonal I will be getting, right? Understanding or not? So the proof and all that, all the things will be covered in the gate course, right? For this HL examination, try to remember this thing. That means K maximum will be, tau maximum will be 4 by 3 times of tau average. And what is the tau average formula? P by pi by 4 d square. P by pi by 4 d square. That is what tau average. Now, once it is done, please let me know. Yes. Now, so we'll try to draw the, for I section, suppose. What will be the distribution for I section? How the distribution will go? Tau average means, see, tau average will be load by area. Shear load by area. Suppose you are calculating for circular cross section. It is not same for every cross section. I mentioned area, right? If area will be different, tau average will be different. P divided by pi by 4 d square. Suppose you want to calculate for square cross section. Square cross section, then tau average will be P divided by A square. Right? So I section, if you just draw I section, if you just draw the I section, symmetric I section I am drawing. a symmetric eye section I'm drawing, which is having a neutral axis exactly at the mid height of this eye section length. How the distribution will be look like? Where the tau will be maximum? Just think and tell me, all of you. Let me give the points also, so it will be more interesting. Point number 1, point number 2, point number 3, point number 4, point number 5. Where it is going to be maximum? Of course, 2 and 5 again same thing because of the symmetricity of the nature. So load will be acting parallel to the cross section. Load will be acting parallel to the cross section. See, if you take any beam and when you apply the force P with respect to cross section, it is acting parallel or not? Tell me, guys. Right. Now, try to think and tell me what will be the distribution. Whether distribution will be A option. The distribution will be like this. Option B, the distribution will be like this. Or the distribution will be something like this. None of the above. Take your 2 minutes of time and then please let me know. Just 2 minutes of time. Yes. So all of you are agree with the option C. So without derivation also we can draw the diagram. I will show you. See. Without having any derivation for this I section, we can draw comfortably. We can draw comfortably this diagram. Option C is correct. Now check it out why. See. So here if I draw, point number 1, point number 2, point number 3, point number 4, point number 5. So first of all, you know that each and every point in between the points, the diagram will look something like a parabola. So 1 to 2, 1 to 2, it will be something like this. But suddenly, suppose consider point P just away, not that much distance. I'm showing you junction point. I'm just showing you junction point. P and Q point. P and Q point. P is just this particular thing we call flange section, and this is called as web section. Now just focus on the flange section. Flange section means in this one, the P point is what? In the flange section. The moment you are just jumping from P to Q, you know that the tau is what? Inversely proportional to what? 1 upon B. When width will be what? Decreases, tau will increase suddenly. Suddenly tau will increase like anything. So whatever at this point, whatever the calculation is there is tau in the flange section. But here it is increased because of what? Tau with the calculation with respect to what? Web section. Again, from 2 to 3, there is a parabola variation like this. And it is going to be increased maximum value. It is going to reach to what? Maximum value, my dear friend. And after that, again, it is going to be decreased to what? Same. Like this. Suddenly, if you jump from what? Again, from point R to point S. Suppose you're jumping from R to S. Again, width is what? Increased. Width will be increased. Then what will happen? It will decrease. Then again, it is coming back to 0. That will be the diagram. Understanding? In fact, this particular method you can follow for any cross section, which I am asking you afterwards. After this question, I will be asking you one more question. Through that, you can just answer me. Right? Perfect. Now, so tau maximum will be at the tau neutral axis. Now I will be asking you the next question. What will be the tau neutral axis magnitude? You got it, that is the maximum. But what is the value? So I'll asking you, what will be the value actually? And what you will just say. At the neutral axis, if I'll asking you, what will be the tau value? That is what the next question. It's a very simple. Follow the trick which I applied to what? Rectangular cross-section derivation. You will be getting the exact answer. Do not worry. See, what is exactly at this particular point of time? What is my layer? What is my fiber? My fiber is what? This one, the green color one. Exactly at this point, I need to determine the tau value. And somebody said that consider the area, hatched area above that fiber. Consider the hatched area above that fiber. Yes or no, guys? Consider the hatched area above that fiber. Yes. All of you, please check it out. All of you, please check it out. Yes. Tell me, guys. Perfect. Now, after this one, how to calculate further? See, this is my tau neutral axis. Where I can show here. So this is my figure right now. This is what my figure is there. First of all, I'm going to calculate what? This thing, How to calculate this thing? See, what is the tau neutral axis formula? What is the tau formula? F into AY bar divided by I multiply with the what? Width of that particular fiber. Width of that particular fiber. See, so tau neutral axis, if I'll be if finding you the tau neutral axis, F I will be putting, AY bar will be I will be putting like this, divided by I neutral axis I will be putting like this, and width of the web section I will be putting simply. That will be my answer. But here, my dear friend, there is a two area. So here AY bar will be what? Summation, simply. Understanding? That means summation of the what? Flange area into Y bar, and summation of what? Web area into what? The height from that centroidal axis. So first of all, I will be calculating AY bar of the flange section. What will be the area? Suppose the thickness will be given to you, width will be given to you. Through that, you can able to find the values of what we want what area. Once you calculate the area, how to calculate the Y bar of the flange section? How to calculate the area of the flange, YF bar of the flange section? It will be something like this. Centroidal distance, like this. Check it out. All of you, please check it out. And for this one, my dear friend, for this one, how to calculate this one? First of all, we need to calculate area of the web section and the centroidal distance from the what? Neutral axis. Like this. So simply what I will do, tau at the neutral axis will be F, area of the flange section, YF bar, plus area of the web section into YW bar, divided by I neutral axis into width of the web section. Check it out. All of you are understanding what I'm saying? Tell me, guys. All of you are understanding what I'm saying? How to calculate the shear stress at particular fiber? Check it out. Correct. Now, once it is done, please let me know. Once it is done, please let me know. Now, if I'll be asking you the different diagrams by different, let me know the answer, how the answer will look like. Now, try to see. I'll be giving you the answer, something like this. Sorry, question will be given like this. Take your time and let me know the answer. There is a plus symbol. Symmetric plus symbol is there. Not unsymmetric, symmetric. So there is a web section. Suppose this is the flange section. What will be the shear stress distribution? What will be there? The shear stress distribution. Option A. Option B will be Option C will be option D will be none of the above. Take your time. Yes. So all of you are agree with the option C. Okay, perfect. So maximum, all of you are telling me the answer C. It's correct only. Of course, why there is a no. See, neutral axis is here, but it is having the not maximum value. Neutral axis, it is not having maximum value because the reason is being that at the neutral axis, a large amount of width is there, and you know that tau is what inversely proportional to width for the same shear force and area into y bar and what something like that. So here it will be here at the junction point just above. If I consider point P, it will be having maximum value. You can take. The moment you just enter into the flange section, it is going to reduce. Why there is a sudden reaction? Because of junction. Because of junction. Now, when you enter into the keep on downward direction, it is keep on decreasing. Sorry, it will keep on increasing. Of course, it will keep on increasing because of parabola conditions, but it is going to have the least value among this particular zone. If I just focus on this zone, it is going to have the least value. So, of course, it is not having zero value, but not maximum also, right? Very important. Now, so I'll be giving you one more problem. Done, all of you? Is it done? Let me know once it is done. Okay. Now try to solve for this one, T section. For T section, suppose the neutral axis will be here somewhere. What will be the shear stress distribution? The option A will be option B will be Option C will be symmetric parabola, or option D will be none of the above. Is it done, all of you? Okay, so right option will be A. It's a very simple. First of all, it will decrease. It will keep on decreasing. First of all, right? Right now. So when it will decrease after junction point, suddenly the width will be decreased. The moment width will decrease, B value will decrease, tau will increase, and it will reaches to what? Maximum value. So again, the neutral axis is not going to have the maximum value. Not going to have the maximum value. The junction point is going to be what? Tau maximum. Tau junction. That is very, very important. Now, so try to solve this one. I think very, very simple. You can able to answer me. An I section subjected to transverse shear force, the maximum shear stress will be developed at flange section or web section. That we need to identify first of all. After that, you can able to answer comfortably. So here exactly, you know that when you draw the I section, it is going to be increased like this. So it is going to be maximum at the center of the beam. So option C, right? Note down. Okay, done all of you? Yeah, so try to solve this question. After this question, we will start deflection. So very first of all, in beam is there, which is a simply supported beam. Now it is subjected to uniformly distributed load. Over a span of 12 meter. And they're asking that, sorry, not UDL load, they are acting upon by the load called concentrated load. So that's a very simple problem. At the mid span, calculate the maximum bending stress that has been introduced, right? B. All of you are getting the B option. In this, my dear friend, I'm having the doubt. Suppose plus symbol is there, which I have shown you, the distribution. I told you that the diagram will be like this. Suppose the diagram is like this, but there is a possibility also, right? Like this. If you just look at very carefully, my dear friend, there's a possibility. Can you think of this? It can be a maximum also. Check it out. Suppose, which one is correct? Like most of the time, which one the diagram will be drawn by the most of the student? Yes. In most of the cases, what will be the diagram? Yes. I'm agree with you. Whatever you are saying, that is correct, but I believe that this diagram will be correct. This will not. I think so. Right? Yeah. Coming back to the question that we are discussing. Now, so what the question we are discussing? We are discussing the question that the maximum bending stress they are asking. A simply supported beam which is subjected to the point load. What is the maximum bending moment? What is the maximum bending moment? W is there. This is W by 2. So you can calculate W by 2 into L by 2. WL by 4, right? 80 into 1000 into 12 into 1000 by 4. That is what my bending moment. Now we need to calculate the bending stress. So 80 into 1000 into 1000 into 12 by 4 into Y. What is the Y value? Y value we can take, the dimensions they have provided 200 mm and 120 mm, because 1 centimeter will be 10 mm. So it is 100, and the what? Moment of inertia calculation will be what? 180 into 200 Q divided by 12. So now if you just calculate, what will be the answer? It's 300 megapascal, right? 300 megapascal will be the answer. In the same problem, I will be asking you one more question. Try to answer me very carefully. Question number 2. In this same problem, data is same. Instead of bending stress, I'm asking you maximum shear stress. Option A I'm giving you. Let me make the option, because just wait. Let me just think of the option. So I'm giving you in terms of, BD. I'm giving you in terms of BD, and the load will be what? The load will be P. The load will be P. In terms of that, I will be giving you. Understood the question? All of you understood the problem? The length is L. The load is P, that is acting exactly at the mid span. The beam cross section is what? B into D, that is rectangular cross section. They are asking what is the maximum bending stress they are asking simply. So option number 1 will be, this 3/2 P divided by BD, 3/4 P divided by BD, 3/8 Which option will be correct? Try to think and tell. Calculate. First of all, calculate. Take your time. So A is correct, right? All of you please check it out. Whether A, B, C, D. Possibilities can be anything. But I need the answer from all of you guys. Do not keep silent. Only 2% giving me the answer as of now. Just one is Ghosh and another is what? Prabhakar. The remaining guys, please try to answer. If not, let me know. Draw this air force. I think bending moment calculation is over, right? Bending moment calculation, maximum bending stress is over, right? All of you? All of it done with the maximum bending stress calculation, right? Now, so it's a very good problem. Let's see how it goes. Let's see what the answer we are getting. Now, see, there is a beam is there, a simply supported beam, which is subjected to the load P. Reaction forces will be P/2 and P/2 will be the answer. For the answer for what? Reaction forces. The load is acting exactly at a distance L/2, L/2, L/2. And the beam cross section is what? BD. First of all, we need to calculate for maximum shear stress. Suppose somebody is very much interested in applying this formula, P maximum A y bar divided by I multiplied by B. Suppose some of you might be very much interested, sir, maximum will be exactly at the neutral axis. So I'll be just calculating by taking this hatched portion and I will be calculating like this. For that, you need some P maximum also. What will be the P maximum? Whether it is P/2, P/4. For that, you need to draw the shear force diagram. For that, you need to draw the shear force diagram. Now, if you draw the shear force diagram, my dear friend, see, for maximum bending stress, what you do? you will find maximum bending stress among the beam. Maximum to maximum that you can able to find. Similar condition will be there for this case also. The loading diagram, sorry, shear force diagram will look like this. P by 2, P by 2, P by 2. So what is the maximum shear force that can be acting, my dear friend, in the beam? Maximum to maximum, P by 2 or not? P by 2 or not? Maximum to maximum. There's a no P. Check it out. There's a no P. This is what shear force diagram, right? And there is a no P value. Maximum to maximum shear force we will be getting in the whole length of the beam will be what? P by 2. Now put the value and get the answer. Tau maximum will be, P maximum is what? P by 2. Area will be what? Area will be what? B into D by 2. What are the Y maximum? What are the Y maximum? See, it is D by 2 to again half, D by 4. D by 4 divided by I. I is what? B dq by 12. And what are the B? B only. So what the answer you are getting? Check it out. So B and B will cancel out. 1D will also cancel out. And with this one more will cancel out. So P divided by what? We can write over here. P divided by 12P divided by 16. 12P divided by 16. 12P divided by 16. Divided by BD, right? So what the answer you are getting? 3 by 4 B into D. Check it out. Are you getting fundamental clarity? Are you getting fundamental clarity? Option B, right? Option B, right? Check it out, guys. All of you, please check it out. Now, some of you might be thinking, sir, what the hell you are applying? Very long, lengthy procedure. But you only told that the formula is what? 3 by 2 times of tau average. So with that also, you will be getting the same answer. There is no hesitation. What is the tau average? Sir, P average divided by what? Area. What is the average shear force that has been acting in this particular beam? What is the shear force that has been acting? Simply, I would say, in the whole diagram, in the whole length of the beam, what is the shear force that has been acting? Whether it is a P or P by 2. Whether it is a P or P by 2. Whether it is a P or P by 2. Check it out. All of you, please check it out. So now you got the clarity, sir, how to calculate the force. So remember, whenever the diagram has been shown, suppose sometime cross section has been shown you and they have given the force figure, suppose P. Remember, this P might be acting average shear force, acting like a shear force for whole length of the beam. For whole length of the beam. Understanding or not? So it's a P by 2 by area. Now if you substitute P by 2 into BD, you will be getting what? 3 by 4 into B. 3P divided by 4 BD. If you are not able to digest this, try to follow exact method. Right? Understanding or not, all of you? All of you understanding? Correct. So this is what the difference, right? This question has been asked, I think single time, GATE 2004 or 5, I don't know. One time they have asked. A similar pattern question they have asked. So basic fundamental thing will always be tested once you. Now again, some of you might be thinking, sir, sigma B you told that my by I. But suppose if I'm taking movement about x-axis, but I need to take the distance from the x-axis only. Some of you might be thinking, sir, why? Why not this distance? That has been clear when you see the derivation. But the derivation, if I cannot explain over here because of the time limitations, right? Explanation of the diagram and each and everything will be provided in the what? Gate course, my dear friend, right? So all of you are getting my point, what I'm saying? Tell me, guys. All of you understanding? Yeah. So due to some reason, I'm just closing right now. Maybe tomorrow we don't have any class for the SOM. Other subject you have. Day after tomorrow, I think we have the sixth class. In that, I will be covering principal stress and strain, Bohr circle. Principal stress and strain and the Bohr circle. That is very easy, very important, and a lot of confusion is there among the students. Which plane we have to take, what angle we have to take, whatever the sign convention, I will tell you. Follow that. You believe me, you will never forget in your whole life about the principal stress and strain. That is the first thing. After that, we will try to cover the thin cylinder, thick cylinder, then columns, then deflections. Right? These four topics remain left, and some part of the strain energy that we are going to cover. Of course, that strain energy I will take in the deflection method only. We have the four methods to find the deflection. One is Castigliano's method. In the Castigliano's method, I will be covering this strain energy, because that method will be used. That method will use what? Bending, shear force calculation for that beam. To find this deflection, see, Castigliano's, if you just find, according to Castigliano's theorem, if you just differentiate this total strain energy with respect to y, with respect to w, then you will be calculating what? You will be calculating the deflections. So there I will tell you how to calculate the strain energy. So do not worry, right? Yeah. So yeah, thank you all. Yeah, you can leave for the day. Yeah.